Hi everybody, in this video we are going to talk about the volume of prisms. The volume of an object literally means how many unit cubes, also known as cubic units, would fit inside that object. So take a look at this picture over here. Each one of these cubes would be called a unit cube because the length would be 1, the width would be 1, and the height would be 1. So we call this a unit cube or a cubic unit. Can you figure out how many cubic units make up the rectangular prism below? So first of all, this would be called a rectangular prism because the base is a rectangle. Actually, the bases are rectangles. This would be one of the bases of the prism. And then if you can imagine that you were Superman or something and you had X-ray vision, then you could see the other base of the prism right over here. The definition of a prism, by the way, is a three-dimensional object with two bases, and those bases are congruent, so they're the same, and they're also parallel to each other. So they're not like this, they're moving in the same direction. And all of the other faces are parallelograms. So this object here meets that definition because it has two congruent and parallel bases, and all of the other faces are parallelograms. This is a parallelogram, this is a parallelogram. Okay, in fact, all of the faces here are rectangles, but rectangles are types of parallelograms. Okay, so anyway, back to this question over here. Can you figure out how many cubic units make up the rectangular prism below? So you can figure that out either by counting every single one or figuring it out in some other way. All right, so pause the video and see if you can do it. The answer is 30. Okay, 30 of these cubic units would be able to fit inside of this rectangular prism. You might have figured that out just by counting them. So here's one. Here's another one. So that's 2. Here's another one, that's 3. So there are 5 over here, and then 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in the front, and you can see the back is the same. So there would be 15 in the front, 15 in the back. So that makes 30. That's one way that you can figure out what the volume is, by counting every single cubic unit. But we're not always going to have a shape, first of all, with so few cubic units that we can just count every single one. And second of all the cubic units are usually not drawn so nicely, so we wouldn't even be able to see them. So we need to figure out another method for figuring out the volume. So let's move on here. In general, we can figure out the volume of any prism, not just a rectangular prism. So the base doesn't necessarily have to be a rectangle. It could be any other shape. We can figure out the volume of any prism by multiplying the area of the base by the height. Okay, so that's the rule. To find the volume of a prism, multiply the area of the base by the height. But now let's go back to the rectangular prism from the last slide and see if we can, see if this makes sense intuitively. This is what the base of that prism looks like without any cubes stacked on top of it. So if we go back to this slide over here, and remember to put your Superman X-ray vision glasses back on. If you were to look at the base of this prism, then it would look like that, right? So that's the picture that I have over here on the next slide. What is the area of the base? Well, the base is just a rectangle. I know that it doesn't look like a rectangle over here, but you have to think three-dimensionally. It doesn't look like a rectangle because when you take a rectangle and you try to draw it on the screen, which is two-dimensional, you have to sort of bend the lines a little bit. But this is a rectangle over here, and so we can figure out what the area of this rectangle is simply by multiplying the length by the width. So the length is 1, 2, 3, 4, 5 units long, and the width is 1, 2 units long. So the area of this rectangle is 10 units long, 10 square units. Okay, so 5 units times 2 units is 10 square units, or we can write it like this, units squared, which literally means that 10 little squares could fit inside of here, and we can see that from the picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the area of the base is 10 square units in this example, the base of this object right over here. Now, if we stack one level of cubes onto the base, how many cubes would there be? So the base was 10 square units. Now we're going to stack cubes on top of the base. How many cubes would be able to, would there be if we did that? Well, imagine that the base that we saw before is made up of little slots that the cubes are going to be put into. There are 10 slots, and each slot is going to get just one cube stacked inside of it or on top of it. So to answer how many cubes there would be, we would just do 10 times 1, which is 10. Okay, and remember that 10 was the area of the base, and this stacking of cubes is just one level high. Okay, and the answer that we get here is that there would be 10 cubic units. On the other hand, what if there were 2 levels or 3 levels of cubes that were stacked on top of the base? Then how many cubes would there be? Well, again, there are 10 little slots on the bottom, but this time over here we're putting 2 cubes on each slot. So we would have 10 times 2, which is equal to 20. So 20 cubic units for this one. Over here, we would have, again, 10 is the number of slots on the bottom, okay? 10 is the area of the base. But this time we're going to multiply by 3 because there are 3 cubes that are stacked on top of each slot. So the total number of cubic units would be 30. Okay, so you can start to see where the general rule comes from. All we're doing here is we're taking the area of the base, which in this example was 10, and then we're multiplying that by the height, right? Here, the height was 2 units. Here, the height was 3 units. And that's how we're figuring out how many cubic units would be there would be. Okay, so let's put the units back in here now. I just wrote these as numbers here, but the area of the base is written in square units, so the exponent here would be a 2. The height would just be regular units, okay, whatever the units are, okay, inches, centimeters, whatever they are. So if we do units squared times units, then we get units, let me erase this because it's in my way now. Then we would get units to the 3rd power, okay, so that's also something to keep in mind. Volume is always written as units to the 3rd power, so centimeters to the 3rd power, or inches to the 3rd power. And the way we would say that is cubic units, so cubic centimeters or cubic inches, and so on. All right, moving on here. The principle of finding the volume of a prism by multiplying the area of the base by the height is the same whether we're talking about a right prism, meaning one that makes a 90-degree angle with the ground, or an oblique prism, meaning one that's slanted. Let me pause there for a second. So the prism that we saw in the very first slide was a right rectangular prism. Rectangular because the base is a rectangle. Right because the base forms a 90-degree angle with the side. Okay, this is 90 degrees right over here. All right, a right angle is 90 degrees, like the corner of a square. All right. Now imagine that we were to take this prism here and kind of bump into it and push the cubes a little bit to the right, so that maybe in the end, I don't know, maybe we're clumsy and we didn't see it there, and then we were walking somewhere and we just banged into it by mistake. Then what would it look like? It would, let's say it looked something like this now. I hope you understand what I mean by this, right? So we just kind of bumped into the prism and we pushed all the stacks to the right. Would there still be the same number of cubes in here as there were in here? The answer is yes. Okay, when we bumped into it and we got all the cubes kind of messed up and slanted like this, we didn't change the number of cubes that there were. So the volume of this would still be the same as the volume of this. Okay, so you don't have to worry when you see a prism and you're trying to calculate the volume of it. You don't have to worry about if that prism is a right prism, meaning it's like standing straight up. Okay, so the side is forming a 90-degree angle with the base. Or if it's an oblique prism, meaning it's slanted like this, so that this is not a right angle over here. That doesn't matter because the volume formula would still be the same. It would still just be the base times the height. What you do have to be careful of is that the height is always perpendicular to the base. So even though this is slanted over here, the height is still perpendicular. So this would not be the height. And if we were to try to calculate the volume of this oblique prism over here, and somebody told you maybe that, I don't know, that this side was 9 inches long, that would be information that you would not even need to use. Okay, what you want is the height of the prism. So if the height was, let's say, 8 units long, you would use the 8, not the 9, in calculating the volume. Okay, so the principle of multiplying the area of the base by the height is the same whether we're talking about a right prism or an oblique prism. And it's also the same if the base is not even a rectangle. Okay, so look at these examples over here. Here, the base is a triangle. In both of these examples, the base is a triangle. In both of these examples, the base is a circle. Okay, but you would still, to find the area of all of these shapes, just multiply the area of the base by the height. Okay, now technically, this is not even a prism. This is a cylinder. These are cylinders over. This would be a right cylinder. This is an oblique cylinder. it's technically not a prism because if you remember earlier in the video, I said that to be a prism, the faces would have to be parallelograms, not curved like a cylinder here. But you would find the volume of a cylinder in the same way as any prism. You just find the area of the base and multiply it by the height. Okay, so knowing that, can you figure out the formulas for the volumes of a triangular prism and a cylinder? So I already gave you the volume for a rectangular prism. It would just be the length times the width times the height. Now, where does that come from? Well, it comes from the fact that the base is a rectangle. And how do we find the area of a rectangle? It's just the length times the width. So the base of a rectangular prism is a rectangle, and the area of a rectangle is length times width. So the base would be length times width, but then we would also have to multiply that by the height, and that's where this formula comes from. So to find the volume, we would do the base times the height, which is the length times the width times the height, okay? Now, what would the formula be for a triangular prism? That is a prism that has a triangular base, because a lot of students would look at this and they would simply multiply all the numbers together, like for a rectangular prism. You can get away with that for a rectangular prism. You see 3 numbers here, you just multiply them all together and you get the right answer. That's not going to work for the other shapes. So you have to think about it step by step. You have to find the area of the base. So look at the base and see what shape it is. And then remember the formula for finding the area of that shape. And then multiply that by the height, okay? So the idea of doing base times height is the same no matter which object we're talking about, but what's going to be different is how we find the area of the base, because we have different shapes here. So in the case of a triangle, how do we find the area of a triangle? So I wrote an L over here for the length of the triangle. And for the height of the triangle, I didn't use the letter H because I'm already using that letter to represent the height of the prism itself. I used the letter P sort of as a reminder that the height of a triangle should be perpendicular to its length. Okay, so if this is the height of the triangle, which is P over here, then to find the area of the base, we would do L times P divided by 2. Remember, the formula for the area of a triangle is base times height divided by 2. I'm calling them different things here. Instead of base and height, B and H, I'm calling them length and the perpendicular height. But it doesn't really matter what you call them, right? So we have L times P divided by 2. But then that just gives us the area of the base. We still need to multiply it by the height. Okay, so we could write it like this, times the height, or we could just put that H right in the numerator. Okay, and that would be the formula for the volume of a triangular prism, a prism with a triangular base. Now, what would be the formula for the volume of a cylinder? Well, for a cylinder, the base would be a circle. Now, how do we find the area of a circle? It would be pi r squared. That's how to find the area of a circle. Okay, and then we would still have to multiply by the height. So that's it. For a cylinder, the volume for the formula for the volume of a cylinder would be pi r squared times h, where r stands for the radius of the cylinder and h stands for the height of the cylinder, and of course pi is pi. Okay, let's do a couple problems here. The radius of a cylinder is 12 centimeters. The height is 30 centimeters. What is the volume of the cylinder? Use 3.14 for pi and show your work. Okay, so first of all, it might be a little bit strange to see the height drawn horizontally like this. But remember, the height is always perpendicular to the base. So, I have a glass over here that's like a cylinder. If this is the base of the cylinder, then this would be the height. But if I just tip the cylinder over, I hope there's no water in here, then this would be the base and this would be the height. Okay, but the base would still be perpendicular to the height even after I tipped it over. All right, so the height is not necessarily always vertical, it's just perpendicular to the base. Okay, so anyway, we have a cylinder here. So how do we find the volume of a cylinder? It would be the base times the height. The base here is a circle. So how do we find the volume? How do we find the area of a circle? It's pi r squared. Okay, so we have volume is equal to the area of the base, which is pi r squared, times the height. So let's put h in there. And now let's just plug in what we know. We know that the radius is 12 centimeters, so we'll plug that in for r. We know that don't forget the exponent, by the way. We know that the height is 30 centimeters, so we'll plug that in for h. Okay, now we'll also actually plug in, because we're told here to use 3.14 for pi, we'll use that approximation for pi. Okay, and the rest of this we can do pretty easily in a simple calculator. So we want to do 3.14, times 12 squared, which means times 12 times 12, times 30. And that would be our answer, 13,564.8. And the units here would be cubic centimeters. So we're going to write cm for centimeters and then put an exponent of 3 there. Okay, volume is always in cubic units. Let's look at the next question. The volume of a triangular prism is the volume of the triangular prism below is 30 cubic inches. What is the height of the prism? This time we're told what the volume is. We have to figure out something else. But let's first just write the formula for the volume of a triangular prism. Remember, volume is always base times height. You don't have to memorize every single formula for each of the different types of prisms. You just have to remember that volume is equal to base times height. And then you can see that if the base is a triangle, then you just have to remember how to find the area of a triangle. The area of a triangle is 1/2 times the base of the triangle times the height of the triangle, or what I called a few minutes ago, the length of the triangle times this perpendicular length over here. So I'm just going to write 1/2 times L times P, or in other words, L times P divided by 2. Okay, and then times the height, so times H, but I'm just going to put that in the numerator. You don't have to, it doesn't really matter. And then we'll just plug in what we know and solve for what we're looking for. So the volume is 30 cubic inches. We're going to plug that in for V. The length here we can see from the diagram is 4 inches. So that's for L. Okay, this, which is really the height of the triangle, is 3 inches. We're looking for the height of the prism. We don't know that yet, so we're just going to keep that H there, then divided by 2. There are different ways that we could solve this problem. We could multiply both sides by 2, and then divide both sides by 4, and then divide both sides by 3. What I'm going to do over here is simplify this. So 4 times 3 is 12. 12 divided by 2 is 6. So I can write 30 equals 6 times H. And then I can divide both sides by 6. So h is equal to 5. So the height of this triangular prism is 5 inches. Height is one-dimensional, so it would just be inches, not square inches like for area, not cubic inches like for volume. Okay, so that's it for this video. I'm going to end it there, and have a great day.